Hey, good morning, everybody. Mr. Decker here. This is going to be the final lesson in Unit 1. Before we start, though, I did want to make sure that if you're not already having the assignment up as you watch this video, I would recommend doing this. So I would actually get your assignment started, make it into a smaller window over here, and then work through these problems as you watch this video. The way that I present these problems usually fall in a very similar order to the way that these problems appear in this assignment. So make sure that you complete it simultaneously as you're watching the video. All right, let's go ahead and get started here. With dilations, typically I dilations is what's most frequently associated with dilations. So again, it's dilations, not dilations. In this lesson, students will be able to perform dilations of figures given a scale factor and also identify the center of dilation and the scale factor given a dilation. So this GIF right here actually demonstrates kind of what a dilation is. Notice how we start off with this smaller quadrilateral here, and then it becomes bigger. And it looks like it's getting further away from the origin. So actually, the center of dilation we're using is the origin. And notice how this point right here started at 2, and now it's at B6. That means that this became 3 times the size, or a scale factor of 3. So we could also look at maybe A, or this right here starts at 1, and now it's up at 3 here. So again, increasing by a scale factor of 3. That's kind of basically what dilations are. It makes a figure smaller or bigger depending on whatever the scale factor is. The scale factor we denote as K. K is what stands for the scale factor. And just keep in mind that dilations are a change in size and position of a figure, but it does not change the shape. Same shape, bigger, smaller, maybe in a different location. Now, if the scale factor is bigger than 1, then it will become bigger. If the scale factor, so this is an example of a scale factor of 3, so notice how it became bigger. If K is a fraction, or if it's smaller than 1, then the dilation will actually shrink. So if our scale factor is 1/2, we start off with our pre-image. Whoops, so this should be pre-image and image here. So this is a little bit backwards. So again, this would be our pre-image. This would be our image because pre-image is before, image is after. So this picture is incorrect. I should have done that first, or take a look at this first. But anyways, notice how it became smaller. That happens whenever the scale factor is a fraction. Now, the notation for dilation is pretty similar to what we looked at before. We got the capital D, stands for dilate, which changes the size, not the shape. We have that K value, or whatever number or fraction is there. That tells you if you're going to make it bigger or smaller depending on whatever number it is. If it's a fraction, it's going to be smaller. If it's a bigger than 1, then it's going to be bigger. The C stands for the center of dilation. We are typically going to use the origin, but we will also dilate from other points. So stay tuned for that. And then as always, whatever comes after everything is kind of the figure that you are dilating. All right, so the best way to look at dilations is just to go ahead and do one. So performing a dilation. This looks very similar to problem 1 in the assignment, except we're doing a scale factor of 2. Notice how this is a 2 instead of a 3. So what that means is we're going to take this figure and we're going to make it twice the size. So we're going to make it larger. And we're going to do that using this O as the center of the dilation, meaning that we're using the origin. So step-by-step process kind of works like this. Step 1 is we're going to determine what the scale factor and center of dilation is. Since this number is 2 here, that means my scale factor is 2. Since it's bigger than 1, it means we're going to enlarge it. Our center of dilation, or C, is the origin in this case. Whenever it's the origin, there's actually a pretty fast way to do this, and we'll look at that in the next slide. But step 2, what we're going to do is from the center of dilation, meaning the origin in this case, so we're going to start at 0, 0. You're going to determine how many units left, right, up and down each point is away. So like starting at the origin here, A is going to be 1 unit to the right, 2 units up. B is just 1 unit up, not left or right at all. From the origin, C is 1 unit to the right and then 1 unit down. And then from the origin, D is 3 units to the right, 1 unit up. So all you're going to do is just take stock of the distances they are away from your center of dilation, which in this case is the origin. Again, this can change depending on whatever this letter is here, so if it's not an O. So now what we're going to do is just take all of these dimensions. So like A was 1 right, 2 up, so we want 1 right, 2 up. And now since our scale factor is 2, we're just going to double those distances. That's all you have to do to dilate. So apply the scale factor. We're going to multiply these by 2. So A will now be, or A prime will be 2 right instead of 1 right, and then 4 up instead of 2 up. So we're just doubling these distances. So 2 right, 4 up, that means A prime is going to be right here. B is just going to be 2 up because we're just doubling this. C should be 2 right and then 2 down. Again, you're just doubling the distances that we measured in step 2. And we should get this dilated figure right here. So again, B went to 0, 2, A went to 2, 4, D went to 6, 2, and C went to 2, negative 2. So there is a shortcut that I said on this slide. I'm just going to show you the shortcut. You can only use this shortcut whenever our center of dilation is the origin. So this shortcut only works if you're using the origin. If it's not the origin, you can't use it. Just don't even try to use it. So if our center of dilation is the origin, it's pretty straightforward. All you do is you figure out where these points are to start off with. So we'll start off with our pre-image coordinates. So A is at 1, 2, B is at 0, 1, C is at 1, negative 1, D is at 3, 1. Now, our scale factor is 2. Whenever it's the origin, that's our center of dilation, you can just take your scale factor and multiply every single coordinate by the scale factor. And that's where your new point is going to be. So if we multiply each coordinate by a scale factor of 2, we got 1 times 2, we got 2 times 2, 0 times 2, 1 times 2, and then every coordinate in every point we're going to multiply by 2, and it'll tell us what our new points are. So A prime will be 2, 4, 0 times 2 is 0, 1 times 2 is 2. For C prime, we got 1 times 2 is 2, negative 1 times 2 is negative 2, and we should get our points, and it should look exactly like the last problem because it's the exact same as the last problem, except this is the shortcut method. So you could feel free to use this on problems or on the assignment problems 1 and 2. We'll go ahead and look at another couple examples here real quick. So this would be an example where we're performing a dilation where our scale factor now is 1/2. So that means it's going to be smaller. And origin is the center of dilation, so we're still using the origin. Since the center of dilation is the origin, we can use the shortcut. We can figure out what all these points are. A is at negative 2, 2. B is at 0, 6. C is at 2, 4. D is at 4, 0. And then you just multiply by 1/2, and that'll tell you what your new coordinates will be. Or you could stick with the same. So 1 second. So step 1, determine the scale factor and center of dilation. We already did that. So again, our scale factor is 1/2. Origin is our center of dilation. If you want to stick with the traditional way, you can actually just, again, count the number of units left or right each point is. So A is 2 to the left, 2 up. So if we're going to make half that, it'll be 1 left, 1 up. So A prime would be right here. Since B is just 6 up, half of that would just be 3 up. So B prime is going to be right here. For C, it's 2 to the right, so half of that is 1 to the right. And then it's up 4, so divided by 2 is going to be up 2. So we go 1 to the right and then up 2, so C prime would be right here. And then you just apply the scale factors, so multiply by 1/2. And like we kind of said, you're going to get this new image here. Again, dilation should not be too tricky here. You just figure out where your center of dilation is, count how many units each point is away, and then apply the scale factor. So again, the shortcut method, whenever you have the origin as your center of dilation, you can just write down where your points start and then apply the scale factor to every single coordinate. So this would be negative 2 times 1/2. Multiplying by 1/2 is the same thing as dividing by 2. So negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. Or if you want to say multiply by a half. 0 times a half is 0. 6 times 1/2 is 3. 2 times a half is 1. 4 times a half is 2. 4 times a half is 2. 0, 0. And you get your new points here. So again, the shortcut method is faster for doing it by the origin. Now, there is examples here that we're going to look at is how to do it by a specific point. So, performing this following transformation, we have dilation, scale factor of 3. We're using point P now as our center of dilation. So, this is all going to follow the exact same way that we did the initial dilation on the very first slide, or the third slide there. First, figure out what your scale factor and center of dilation are. So our scale factor is 3. That means it's going to get bigger. Our center of dilation is P. P is this point right here, which is at negative 1, 4. So now, all you're going to do is from your center of dilation, so from point P, count how many units each point is away. So like to get to A, we got to go 2 units. And now since our scale factor is 3, to enlarge this, we're going to go 3 times 2 is 6 units. So from P, I'd count 1, 2, 3, 4, 5, 6. A prime is going to be right here. But again, all you're doing is counting how many units each point is away from your center of dilation. So in this case, it's not the origin, so you can't use the shortcut. So again, you can't use the shortcut if the center of dilation is not the origin. Count how many units each point is away. So B is 2 to the left, 1 down. C is 1 to the left, 3 down. And now we'll just apply our scale factor of 3. So we're going to multiply by 3 all of these units to get our new distances away. So from P, A is just going to be 6 units down. Oops. So A is just going to be 1, 2, 3, 4, 5, 6 because we multiplied this distance by 3. B, instead of being 2 to the left, 1 down, it's going to be 6 to the left, 3 down, because again, you're multiplying those distances by 3. And then C is going to be 3 to the left, 9 down, and we'll get this figure right there. That is the dilated image, or the dilated image of triangle ABC by a scale factor of 3, using C as the center of dilation. All right, we're getting kind of close on time here, so let me wrap this up. So this is just a quick notes. Whenever the center of dilation is not the origin, you figure out what your point is. So our point here is P. Figure out the distance away each point is, and then multiply the scale factor to figure out where your new points will be from the distance from our center of dilation, in this case P. All right, let's just run through this last example here, example 3. This is performing a dilation, so 1/3 means we're going to make it 1/3 the size. We're using B. So B is going to be a center of dilation. So in this case, we're going to look at how far A is. So how far A is away from B. Well, it's 6 units right, 3 down. B is, there's no unit change in B, so there's 0 movement. And then C is 3 to the right, 9 down. And then we just apply the scale factor. Since B is the center of dilation, it actually just stays right where it's at. So B is going to be the same as B prime. For A, again, if it started off 6 units to the right and 3 down, we're just going to divide it by 3 because that's what multiplying by 1/3 is doing. So 6 units right divided by 3 is 2 units right. 3 units down is divided by 3 is 1 unit down. So that means A is going to be 2 units right, 1 unit down, and that's where A prime is. I'll leave this up here for a second, and then we're going to finish this up by looking at this scale factor here. So you can pause this at any time. Now, how to find the scale factor given a dilation is, first of all, you need to figure out what your pre-image and image are. Again, it's usually with these asterisks that represent prime. So this is A prime. That means that this is our after. Now, whenever you're using a scale factor, you multiply your original times the scale factor. So in order to figure out the scale factor, we work backwards. We got to take our after. So in this case, we could take any one of these sides. This is 16.5 divided by the corresponding side, and it'll tell you what your scale factor is. So again, it always image divided by pre-image. this. Running out of time here. I'm just going to flip through so you can pause for these next examples.